Okay, question 10, we are left with 10 more questions. Question 10 reads, the inequality cos x is greater than root 2 divided by 2 with negative pi less than or equal to x less than or equal to pi has for solutions. Option A, 0 is less than x less than pi ln 4. Option B, negative pi ln 4 is less than x less than pi ln 4. Option C, pi ln 4 is less than x less than pi. And option D, none of the above. Okay, so to always solve inequalities, we start by finding the critical values if possible. So here we have a trigonometric inequality. So we need to first of all find the critical values. And the critical values are the points of intersection of the cosine function and the function root 2 on 2. So basic trigonometry, we need to find the principal value and we add it to 2k pi since we need a general solution before deducing the specific solutions in the interval given. So cos inverse of root 2 on 2 is pi ln 4. We don't use calculators in the concours, so you have to look for shortcuts and you have to memorize how to get the cos inverse, the cosine, the sine of angles. Okay, so our general solution is pi ln 4 plus or minus 2k pi. That is the general solution. Now we are solving an inequality, and I'm going to advise you, whenever you are involved with trigonometric inequalities, go by the graph. So we are going to have a graphical analysis where we draw the graph of cos x in the interval negative pi to pi. We now draw the line y equal to root 2 on 2. Okay, so those are two graphs. We have cos x and we have root 2 divided by 2. Now the 2 points of intersection, remember that we are in the interval negative pi to pi, so those two graphs intersect at 2 points. Those are our critical values. Okay, so we can call the first point x1 and we call the second point, we can call the first one x0 and the second one x1. Okay, now what do we need? The inequality we are solving is cos x greater than root 2 divided by 2. So if you look clearly, you're going to see that from x0 right till x1, okay, the cosine function is above the line. That's the interpretation of the inequality. The cosine function is supposed to be above the line. It therefore means that for all values of x that are in this shaded portion here, the cosine function is always above that line. Alright, so what is x1? Our x1 is the principal value, which is this value here, since it is in the first quadrant, 0 to pi ln 2. So it is what? Pi divided by 4 when k is 0. Now what is x0? The cosine function is symmetrical about the y-axis, meaning that the x0 here is just negative x1. Okay, so it's kind of a reflection about this axis. So since this is pi ln 4, automatically this is what? Negative pi ln 4. So the solution set according to our representation here, our x is going to be between x0 and x1. And x0 is negative pi ln 4 and x1 is pi ln 4. It therefore means that option B is correct. Negative pi ln 4 is less than x less than pi ln 4. Then cos x will be always greater than root 2 divided by 2. Okay, question 11. The lines of equations y equal to 1 and x equal to negative 1, A, are parallel, B, are perpendicular, C, intersect at 0, 0, and D, none of the above. So we draw our xy plane, we label the axis, we draw the line y equal to 1, it's a horizontal line. We draw the line x equal to negative 1, it's a vertical line. You clearly see that these two lines are what? Orthogonal or perpendicular, clearly. So option B is correct. Question 12. The solutions of the inequality, the absolute value of x is less than or equal to x plus 1 are A, x greater or equal to 0, B, x less than or equal to 1, C, x less than or equal to negative 1 and x greater or equal to 0, D, x greater or equal to negative half. Alright, so first of all, we define what the absolute value of x plus of x means. Absolute value of x is equal to x provided x is greater or equal to 0 and it is negative x provided x is less than 0. So we are going to define cases here. The first case we are going to replace the absolute value of x here just with x, with bearing in mind that the x is supposed to be greater or equal to 0 according to the definition here. So we go back to our inequality and we replace the absolute value of x with x. We subtract x on both sides and we get 0 is less than or equal to 1. This is something that is always true. It therefore means that the solution here is simply the condition, which is x greater or equal to 0. So for all x greater or equal to 0, this is always true. So that is the solution. So we can call that our first solution. Now, the second case, we now replace the absolute value of x with negative x, bearing in mind that in that situation, our x is supposed to be negative, meaning less than 0. So if we replace the absolute value of x with negative x, we can solve the inequality. We subtract x on both sides, and then we divide both sides by negative 2. The inequality sign reverses to greater or equal to. So the solution is x greater or equal to negative half. Alright, and now there is something. For us to arrive at x greater or equal to negative half, the condition was that your x must be less than 0. It therefore means that the solution is going to be x between negative half and 0, because you are less than 0 and you are greater than negative half. So the solution of this inequality is a union of the solutions of the two cases. So solution 1 union solution 2. We can go to the number line and indicate the two solutions. We have negative half, we have 0. For solution 1, we have to bold enclose our circle and we take everything greater than 0. We can call that solution 1. For solution 2, we have to include negative half, we exclude 0, and then we take everything between the two of them. But the union of these two intervals, or of these two solutions, is the both intervals, meaning this interval and this interval. And option D is going to be correct, x greater or equal to negative half, because you are taking everything beginning from negative half to 0 and then you continue from 0. Alright, so you're taking everything. So the equivalence of the union is simply x greater or equal to negative half. So option D is correct. Alright, question 13. The solutions of the inequality logarithm to the base 2 of x less than or equal to 1 are: option A, 0 is less than x less than 1. Option B, 0 is less than x less than log 2. Option C, x is greater or equal to 2. And option D, none of the above. So the first thing to do is that we have to find the domain of definition of this inequality, because the function involved here is not always defined in the set of real numbers. There are some restrictions to it. So for the logarithmic function to be defined, the argument, which is x, must be positive. So that's the domain of definition of this inequality. Now, since the base of this inequality is greater than 1, we follow the convention. Okay, so we are going to have our x to be less than or equal to 2 raised to the power 1, meaning that x is less than or equal to 2. Listen to this. If the base of the inequality was less than 1, first we have to convert it to a base greater than 1 before we apply the convention, meaning taking x and putting the less than automatically. But when it is greater than 1, we just apply the convention already. Alright, so from here we have that the solution is x less than or equal to 2. But now you can be less than 2, okay, but you are not in the domain, because negative numbers are less than 2. But when we fit a negative number here, the inequality will not be defined. So that was the essence of getting the domain of definition of the inequality. So we now need to intersect the solution with the domain of definition. So we always intersect with conditions. So the condition for this inequality to be defined is that x must be positive. So we are now doing what? We are now intersecting x less than 2 with x greater than 0. Is going to give us x between 0 and 2. Okay, we go to the number line and intersect. You are greater than 0 and you are less than 2. And you can be equal to 2 as well. So it means that you are between 0 and 2. So option D is correct. None of the above. Alright, question 14. In the Cartesian plane, xy, the region xy, a couple belonging in arrow square. This just means that x is in arrow and y is in arrow. That's why if you write it as a couple, it's xy in arrow square. Okay, now the absolute value of x plus y is equal to 1. What is a representation? All right, so first we give the implication of absolute value of x plus y equal to 1. What does it mean? It simply means that x plus 1 will be plus or minus 1. Okay, because it is only plus or minus 1. Now when you take the absolute value, it's going to give you 1. Okay, so x plus 1 should be either negative 1 or it should be 1. Now if you look for y as a function of x, we are going to have two lines. The first line is negative x minus 1 and the next line is negative x plus 1. The two lines are parallel to each other. Okay, and they have different intercepts. So we now go to the xy plane, we label our axis, we now draw the graphs. So these two intercepts are for the first line. When x is 0, y is negative 1, here is the intercept. When y is 0, x is negative 1, here is the intercept. We link the two intercepts and we extend. So we have the first line. Now for the second line, when x is 0, y is 1, that is the point. When y is 0, x is 1, that is a point. We link the two and extend. So which option is correct? Option A. Alright, question 15. We have A. Cos inverse of negative pylon 3 is equal to pylon 6 is equal to negative pylon 6 is equal to 5 pylon 6 or none of the above. So first of all, the sine function is an odd function. So we first of all deal with the interior before taking the cos inverse. So since the sine function is an odd function, it therefore means that the sine of negative pylon 3 is the same as negative the sine of pylon 3. Pylon 3 in degrees is 60 degrees and the sine of 60 degrees is root 3 on 2. So the sine of negative pylon 3 is negative the sine of pylon 3 as we have seen, which is now negative root 3 divided by 2. Now we now need to find the cos inverse of negative root 3 divided by 2. And we should recall that whenever we add the cos inverse of an angle to the cos inverse of negative of that angle, we always get pi. Okay, we can prove it. Alright, but there is no time to do that. So it therefore means that to find the cos inverse of negative root 3 on 2, I will just take pi minus the cos inverse of root 3 on 2. Because we can find the cos inverse of root 3 on 2. The cos inverse of root 3 on 2 is an angle that when you take the cosine of that angle, you get root 3 on 2. And that angle is simply 30 degrees, which is pylon 6. So the cos inverse of sine of negative pylon 3 is pi minus pylon 6, which is 5 pylon 6. So option C is correct. Question 16. For each couple A and B being real numbers, with both of them being positive and A is less than B, we always have option A, arctan B is less than arctan A. Option B, cos A is greater than cos B. Option C, tan A is less than tan B. And option D, none of the above. So I try to draw the graphs of these various functions: tan inverse, cosine, and tangent. So here's a graph of cos x, here's a graph of arctan x in a positive interval, and here is a graph of tan x in a positive interval. Now let us analyze. Let's begin with cos x. Okay, so if A is less than B, does it mean that cos A is greater than cos B? Let us see if that is true. So I pick A to be here and I pick B to be there. Now what is cos A? That is cos A there. And what is cos B? Here is cos B. You see, cos A is a positive value and cos B is a negative value. It therefore means that cos A will be greater than cos B. But what if now I take my A to be 90 degrees and my B to be 270 degrees? So we have A to be 90 degrees and B to be 270. Cos A will give you 0 and cos B will give you 0. You see, they are equal. So it therefore means option B is wrong. Because if A is 90 and B is 270, both of them are positive and A is less than B. But the cosine of A is 0 and the cosine of B is 0. And you come and place here, you are going to get 0 greater than 0. Impossible. So option B is out of the way. Let's now go to arctan, option A. So this is the tan inverse function in a positive interval. It is increasing in that interval. So if it is increasing in that interval, if I take A to be this and B to be this, now if you look for cos A and cos B, we are going to get cos A and cos B to be those two red dots. Our cos A is below cos B, therefore, arctan A and arctan B. Our arctan A is below arctan B because A is less than B, and the function arctan is increasing in the positive interval. Alright, so clearly we see that arctan B is greater than arctan A, so option A is gone. Option A, which is saying that arctan B is less than arctan A, is incorrect. Now let us go to the last graph, which is for tan X. Alright, so I consider A to be here and B to be here. Now if you look for cos A and cos B, we are going to get those two dots. You see cos A is what? Positive. Cos B is what? Negative. So cos A is greater than cos B. These are just examples I'm taking. Alright, you could also take examples that will work because these functions have different sense of variations depending on the interval. There are intervals where they are increasing, intervals where they are decreasing, and the results might be reversed. So I'm just taking random examples. Alright, so you see in this last case, your cos A is a positive value and tan A is a positive value and tan B is a negative value. So you see that tan A will be greater than tan B. So option C is saying that tan A is less than tan B, which is wrong. So what can we conclude? Option D is correct, none of the above.